Okay. So, one moment, I have to switch my presentation. Okay. Often, if you do some things in legacy systems, it feels like being caught in a spider's web, I think. Um, it feels, and you don't feel like a spider, you feel like a captured insect in the spider's web because there are so many dependencies. You have to know the systems, you have to know how they interact, you have to know where's data stored. You do have to know the data model. There are a lot of processes running, and you have a lot of dependencies. System and an operational dependency. I need a new JDK. Okay, you just ask, is this JDK available? Okay, we plan to make it available in 6 months. Okay, it's a little bit too late for my project, so I have to decide to use an older version of Spring Boot, for example, or okay, I need something like monitoring my systems in production. How can I realize that? And just talking to people, and they tell you, okay, it's a little difficult, but if you use our JBoss stack, you get it out of the box. Yeah, you have to get the same information when you're talking about I need a database. Yeah, it's a little bit difficult, but get it out of the box if you choose our JBoss stack, and then you decide to wrap your Spring Boot application into a war in a year and deploy it on a JBoss. And that's what I think every developer knows and experiences every day. If you try to implement new things, you're caught in this existing system, in these processes, in these dependencies, and this makes life often really hard. As I'm a developer, the question, is it possible to avoid dependencies? Okay, it's a rhetoric question. Of course, it is not possible. But the question is, why do such dependencies arise? What's the history of it? What happens? And as I'm a developer, I just say, okay, I make an example. Let's start with a new project. Assume we have to implement the internet banking again. It's on a new technology. That's what I experienced when I joined ING DIBA about 12 years ago. It was the rewrite of internet banking, so it's a good example for me. What do? You start with something like core. You identify the components that you need. It's for internet banking. Okay, you need some UI components, some input fields. You need a navigation. You need a representation of the logged in user. You need a list of accounts that you can access. And yes, you try to build it in something like a core element for reusable elements. And then you start implementing use cases. I assume it's something like payment use cases or brokerage use cases or something like that. And you use the things in core, and the first things that happen is you will experience that it's not sufficient what you did in core. You add some extensions, and you think, okay, perhaps some refactoring could take place, but it's only a small hack just for module A or module B in this case. So, okay, it's okay, and it works fine, and you did your job. And then you start the new module. Let's assume something like administration, addresses, taxes, and so on. And then you find out, okay, there's some code that is only used by some modules, not by all modules. I will extract something like common. Okay, I need common also has a dependency on core because I need something like the accounts, the list of accounts, and the logged in user, but it's better to structure it like that. So the process continues, and you have reached about 80%, and then somebody came up and says, okay, we have delayed some aspects. We need something like we need something like tracking, web tracking. Yeah, we have to find out how the people navigate on our web page. Yeah, we need something like journaling. Yeah, police sometimes requests, and we have to give them some information. We cannot give them a technical log. We have to write a condensed form. Of course, we have some things like consents that have been given, and yeah, it's clear. Yeah, it's central things, and you implement it in core, and you add some things in core, and as you don't want to modify all use cases outside, we've implemented a lot of use cases. Yeah, you really decide to make the short way, extend some base classes in core. Yeah, you add some dependencies. You don't realize. In fact, you don't realize how many dependencies you add inside core, and it's really growing up. Yeah, and then you start implementing the hard 20% use cases. Yeah, it's a typical thing. Yeah, what do you want to do? You just try to delay the hardest things. It's a new technology. You have to gather some experience, and so you start with the easier things, with the things that have to be long in testing, the most used use cases. Yeah, payments and brokerage. Yeah, this must work. You must not implement it as the last use cases. And so use cases like opening, product openings, they are implemented last. So and they are really complicated because they have dependencies everywhere. You have to ask for the address. You have to ask for tax things. You have to need some information for payments and so on. So they just address a lot of things. And as the process has to be, the project has to be finished and timeline is running, you decide, okay, we just reuse, we add some dependencies to other modules, and we just reuse things that we have already implemented. Yeah, and in the end, just have a look at it. Do you see the spider web? Yeah, I see it. Nah? Everything connected with everything grouped around a big bubble. A lot of things inside core that should be a lot of integration inside core. You realize you know it's hard to maintain, but you accept it. And it's okay to accept it. You know that you have finished the project in time. Yeah, they are all lucky. It's working. You can go productive. But if you're honest, you should think about restructuring the whole system, because it's really a maintenance hell. And there are so many dependencies. And if you have a deeper look at it, you've tried to structure the system. Yeah, it's not that you have done all things in one pot. And you've tried to structure your system, and the dependencies are a result of this restructuring. But if you're honest, your structuring is not very well. You should restructure the whole system, and especially you should restructure core, because in core there's so much functionality. There's so much grouped around and so much reuse. And that's what I call them a black hole. Yeah. Such things like core, where so many functionality is integrated, so many responsibilities, such a broad API. Yeah. And as it is the starting point of our project, so many hacks are implemented, degenerated API. Yeah. And this leads to a situation that you sometimes don't know how the system really works. You have to debug into core often, because some unexpected things happen. A lot of usage about it is required. And that's why I say a typical thing is it's for experts only. Yeah. It's a constant point of interest. You always have to search inside it. And to be honest, there's a lot of technical debt inside it, huh? And yeah, you have to accept it. Yeah, the option is to say, okay, the project must be delayed for an additional 6 or 8 or 10 months because we have to clean up. Nobody can accept it, and it's not what you want to do. So the real challenge is that your project has finished, and you know there's a lot of technical debt, and you have to clean up. Yeah, and that's what often not done. And you pay later for things that you do not clean up. Yeah, and I took an example for a software development project, but I think you can apply this pattern on systems also. Yeah, I mentioned this operational thing. If you take our JBoss, you get so many things out of the box. Okay, they've really packed everything in one part, yeah, and this adds so many dependencies. Yeah, all things are high integrated, but they make you use some things that you don't want to use. Yeah, and that's a kind of dependencies that I don't like, and I made a good experience with it. Just to look at such black holes. Yeah. And you can easily identify them. In fact, a lot of things are integrated, and you've got a lot of dependencies. And yeah, you switch back. You can also give dependencies a value. You know, it gives me a value because I reuse something, but it implies costs because if I reuse it, if I want to change this code that is reused, I have to address everybody who's using it. So the quality level should be high, so that I don't have to change the API too much or too often, and that it's clear how to use it. And that's what black holes don't fulfill. Yeah. Yeah. So I just want to show how we address this. An example how we address this in the internet banking. Yeah. In fact, we killed this core element. I moved out everything. Every aspect was moved into a library. Clean API was established. These libraries can be built for their own. And we have now 14 modules in the internet banking that can be built separately. They can be deployed separately. What we did not do just now, because we just put it all together in the end into one running deployment, but that's a detail. And we just focused on restructuring the whole system. And now I give you an example for one task. It's an interesting task, how to eliminate things from something like core, from the black hole. Yeah, we started implementing the internet banking from scratch, replacing the old with new technology. It was Wicked. It still is Wicked. It's a Java-based system based on Wicked and Spring. Yeah, so I have to mention it. Yeah, and if the typical thing is how do you configure your application? And in the old system, there were two systems available. Dependency on a config repo. It was a proprietary development of ING developed in in the 90s, end of 90s. So modern that time, but not modern now. For config repo is for static configuration. Yeah, it's a complicated system, not easy to use. Okay, very powerful. On the other side, we had some dynamic configuration. We required some dynamic configuration, but we had only dynamic configuration just for locking some use cases. Yeah, you have a problem with a database or with an external system, for example. Yeah, you not only depend on your own systems, you also depend on external systems. And if some systems don't work, you have to log the use case just within a short time. There's a production problem. So you tell the customer, okay, the service is not available, try it a little bit later. For this scenario, we had a separate configuration, and we just had some two services inside core just for configuration. And configuration is used everywhere. It's used everywhere in your system. And for every use case, we had to mock the services in tests. It was really not nice, and it's not a good thing, because configuration in this way is not made for the future, and we have to use something more modern. And what we wanted to achieve is to switch to a Spring Cloud config server, to use the Spring Boot constructs for to configure our application. And you have a running system, and you cannot do a big bang thing. Everywhere, so you need a plan, and that's what I want to show. First step was, I wrote an adapter for the Spring environment, so all entries in this database for configuring which use case is logged were made public to the published to the Spring environment and became properties. So you could read a property from a Spring environment. It said true or false. Is use cases enabled or is not enabled? And then we introduced an annotation. It was not implemented in core. It was implemented in a separate library, also based on Wicked. So we could annotate each use case, the classes, with this property. And the property was then read during runtime from the Spring environment. And so we controlled how if the use case is available or not. The nice thing is the service could be eliminated everywhere. No requirement to mock it in tests or something like that. Just write this annotation, a clean, simple API to achieve this requirement. But on the other side, we had to go through the whole code and remove this service. And this was so much effort, really, but it paid off in the end. Really, it paid off. On the other side, we had the configurable thing. If you want to use everything in Spring environment, you have to decide how to do it. We decided to introduce configuration properties. It's also a Spring-based thing. The logic is in a third-party library. And we decided to switch to configuration properties. They are also read by the Spring environment. And then we introduced the Spring Cloud config server. We just changed the implementation of the service. So it just read the things from the config repo, and then it read the things from the Spring environment. After that, the same with the other servers. Remove every usage. Switch over to configuration properties. Was a big refactoring. A lot of work, took some time, but in the end, every usage of the servers was replaced, and then we removed the servers. And then we enabled the refresh feature in Spring Cloud config server, so that we were able to log our use cases on demand. Just change the configuration, trigger a refresh, and the system is reconfigured. And that made it possible to remove everything else. And as you see, it was a long-running process, but with a real plan, several steps that have to be taken, and the system was really simplified. Core things were eliminated. We use things from libraries, so just improved the architecture of the internet banking massively. Yeah. A really important thing is it's a really long-running process. You have to do so many things, and you have to have a plan. You have to do one step after the other. It took about 2 or 3 years from the starting point. Yeah, just to give you an impression, because it's not the only thing that you do. Yeah, you do it if you have time. If you change something, then you do it in parallel. So it was a really long running process. Another thing, the example that I gave you was what I can do inside my application to make my application better, to remove dependencies, to reduce black holes, but you also depend on other systems in your company. Yeah, internet banking, you need backends, you need databases, you need something like an email server for sending some tasks. You have Kafka for sending messages, for informing other systems. Yeah, you have a logged-in user, you have a dependency on a OpenID Connect server, you want to realize file uploads, so files have to be checked before they are accepted for the company, so they can reach the internal network. So there are so many services that you use, servers that you use, and yeah, it's often a problem because you depend on the system, you need them, but not only you need the systems, you also need the test data. And test data, it's so complicated, yeah. Not the common cases. The common cases are fast, it's not a problem, but the special cases are really a problem. And so I just chose to do the following way. One moment, please. Just chose the following way. I cut every dependency. Yeah, really cut it and replace it with mocks or other systems. Yeah, I want to show it like this. Really, the internet banking, we replaced every service with mocks. For databases, we used an in-memory database. Something like an SMTP server, you can provide some provider, can implement some providers that make it possible to serialize the send email on your local storage. So it's easy to test. Yeah, just make the use case. You see the file, how it is serialized. You can take the file and open it in your email client and usually if it's correct or not. Yeah. So we just mocked away everything. And it's interesting. We called it box. It's really massively used during development. It makes us independent from all test systems, environments, everything. If we need a special test case, special test data, we can mock everything. We did mocks respond with the constellation that we need. So we can implement, we can test in our internet banking, and don't have to wait for test data. Yeah, don't have to wait. Don't have to search for them or to wait or something like that. And in the end, it's possible to implement or to program without any connection to the internal network. And that's what I want to show you. I'm not in the ING network, and I've got a running boxed internet banking. And so now I have to switch my presentation. So starten. Sind hier. not working fine now. Okay, here we are. Okay. So just open, this is just what customers do. They type in I'm banking ing.de, and you see they are redirected to another service, access ing.de. It's an OAuth OpenID Connect server. And yeah, if I just open my local running system, you see, okay, I'm redirected to an OpenID Connect server that just is for development and test. Yeah, and you see the headline, and it offers me the opportunity to log in my customers. Yeah, you can see everything is rendered. You can use every use case. You can do a transaction. Yeah, you see everything is working. For example, here you want to get an approval for your transaction. Yeah, this is mimicked. Yeah, simulated. And yeah, what also happens, no state change, okay? It's exact the same amount. Yeah, nothing happened. There's no backend system involved. All responses are mocked. And this makes it easy to replay use cases, to test use cases, to does they work. You can mimic every special case. Our messages displayed correctly. Our testers like it because they can write automated tests. Every time they log in, they found the same information. It behaves always the same. You terminate a session, and it is the same again. Yeah, and this mock box also allows to implement some mocks that have some state change. I can show it to you. For example, yeah, to give back a transaction. Yeah. Example, this one here. Press. You want to have the money. Yeah. Wait a moment. So, okay. The approval is made. Yeah, you go to Umsatz and say, hey, and you got the money. Yeah. So the mock is really powerful. It's a mock system that we implemented. It's really nice. You can easily add test data if you require it for your implementations. And yeah, I think it's a cool showcase. And especially, I'm not in the network. Yeah, every system, the internet banking depends on is mocked away. I have synthetic test data. I really like synthetic test data. Yeah, I hope you enjoyed this showcase. So now I have to switch back. Is this one? Yeah. So does it switch back correctly? Yeah.
Yes, everything works
Okay. So I'm back. So this is a small showcase what you can do as a developer to make your life more easy. It's really fun, yeah, to be independent of other systems, to concentrate on your own system, on your own development. Makes it easy to deliver things fast. Yeah. If I'm talking to backend developers and we need new services, new interfaces, and so on, I just tell them, give me the API. Just give me the API. We'll just talk about the API. And they say, okay, then we define an API. So I take the API, implement everything I need. I can prove if the API really works, if I've forgotten some things, if it feels good. So I can give immediately feedback. And often we are faster than the backends. We are ready with our implementation, and the backend developers are not ready with the implementation. And that's not a typical thing. The typical thing is you have to wait until the backend people have implemented something, and in the end you're the internet banking that uses these interfaces, and process line is running, and you have short time and everything has to be hacked. No, everything under control. You have enough time. You are the driver. It's a real comfortable thing. What can I do say about documentation? Experiences, if you just maintain the system very long. For me, it's nearly 12 years. Documentation is really hard. Some people say you have to document everything, but everything is it's something like it's placed on a heap. It's just stored. You don't find it. It's a lot of documentation. You have to search. Documentation outdates, and my experience is keeping documentation in sync with your system. It's a challenge, and you don't have the time, you don't have the person, and if you then require the documentation, you do not find anything. So just writing documentation so that documentation exists is the wrong way. But what really helps is if you document some basics, some very important things, so that it helps you to understand the code. I say the truth lies in the code, not in the documentation, and the documentation must help me to understand the code. And you should write it so that a third person that starts you can give him the documentation. It helps these people to the developers to understand the structure, to understand how the system works, how the architecture is, and that's all what you need for documentation. And you should focus on this. It's really what I can tell you. And what's really important, this documentation must be of very high quality. Just invest time in documentation, but really focus on the documentation, what you write. That's what I can say about documentation. And then some remarks about modernization of software, or what my experiences. I focus on the black holes, because if you eliminate them, everything becomes really better. But your resources are limited. People, time, projects running. So you cannot do everything. That's really important. So you always have to focus. What do I do? For example, we just use EasyMock for JUnit tests. EasyMock is really outdated. And I had a discussion with the freelancer who said, no, I don't use EasyMock anymore. I want to use Mockito. And I told him, no, we use EasyMock. And you use EasyMock also. Because the problem is, that's not the problem, EasyMock fulfills every requirement. The experience is there. Everybody knows how to use it. I have no profit from moving from EasyMock to Mockito. And there's no requirements. There are no workarounds. So it's okay to use it. For the things that we use it. And if I just introduce Mockito, I have 2 mocking frameworks. And this is more complicated than to have 1. And if I replace with Mockito in consequence, I have to replace everything. Yeah, and that's really important to know. It's not done by introducing something new. It's only finished if you have placed everything of the old one. And that's what I showed in my example before. We had to replace every occurrence of the usage, every usage of these core services before we could remove them. And the system was only modernized after replacing all old things. And that also applies to this thing. It's sometimes okay to not to modernize, really to decide, no, this is kept. Because the implication is I have to rework everything. And what do I profit? What's my value to replace it? And if the value is not high enough and the effort is too much and it's not a real problem, yeah, you can keep it. I also was asked a short time before, why, you've modernized everything, why do you still use Wicked? It's the same argumentation, yeah. It's perfectly matching our requirements. Yeah, after people that are able to use it, we have a lot of experience, a lot of things are solved easily because we know the technology, we know know a lot of tricks, yeah, a lot of things, APIs that are not commonly well known to a lot of developers. And if I have to switch to another framework, I have to start again. Yeah, and in fact, I have to rebuild the complete internet banking so that it's switched to a new technology. Because as long as I use Wicked, I need Wicked know-how. Yeah, so in fact, I have to rewrite the complete internet banking if I replace this framework on the long run. So we just staying on the Wicked, but that's what I want to tell you. Be prepared. Yeah, really be prepared. It's okay that you decide that it's now not the right time to replace it, but there will be the time when you have to replace it. So do everything to make the replacement more easy if it has to be done. This implies that, for example, I have a real focus on that we use Wicked only for what we need it. Yeah, a lot of every business code has to be placed in the Spring Stack. And if I find code in the Wicked things, then I just favor place this code in the Spring code so that the layer becomes as thin as it could be. Yeah, and that's what you can do regularly if you refactor a use case. Every release we try to modernize some use cases to have a look at it. So that we have a continuous ongoing and modernizing and to be prepared. Yeah, and that's important. One of the biggest things to be prepared is that I just make this monolithic system, a system that consists of a lot of applications that interact with each other so that I can start refactoring, replacing things in one module. And this does not require that everything has to be changed. Yeah, it's time for a small summary. What we really have to do is that we have to accept technical debt. Yeah, it's important to become productive. And I just want to compare it with if you want to buy a house. Yeah, you have to accept the mortgage. Yeah, you can. Yeah, the alternative is I have to save money, and when I'm 60, I can buy the house. That's not an option. Yeah, you want to buy the house, so you go to the bank and accept the mortgage. Yeah, and that's the same. Yeah, and you have to accept it. And yes, what you have to do is you have to pay it back. You have to pay back the debt. Yeah, and that's the same thing with that software. You have continuously removed technical debt, because if you don't do it, you have a problem. Yeah, The situation is in software development, we are our own creditor and debitor, yeah. But in fact, we paid with another currency competitiveness. If you do not remove the technical debt, in fact, your system will die. On the long run, it will die. Yeah. There's a good thing to look at dependencies, and to give dependencies a value and a cost. This really directs you to the correct place where you have to focus on. Yeah. So focus what you have to do, the big points, not the low-hanging fruits. No? A manager like low-hanging fruits. No, address the really important things. This will improve your system really. Then a really important thing is you have to be patient. Yeah, I told you that one thing, it was 2 or 3 years, and it's sometimes hard to explain. I have to do it. I have to invest time. It takes a long time, and functionality is added. No, there's no functionality added. So it's sometimes a little bit hard to explain, but as a developer, you know, hey, I do it in the right way. I make it more flexible. It will make my life more easier. The maintenance costs just decrease massively if I do this. Yeah, and you have to address this, and you really have to be patient. It's really important. And you have to be consequent. Yeah, if you replace something, replace it everywhere. Yeah, because if you don't do it, you have two solutions running parallel, and you gain the worst of both worlds. Yeah, and you have just not made your system better. You have decreased the quality of your system. You have done something that, that speeds up the decrease of the quality of the system. Yeah, and then have a look what's coming up. Yeah, if you are prepared, it's a nice thing. I can give you a short story. The tracking library was isolated, but the quality of the tracking library was not so well. Yeah, not so many things happened. But I had a look at it and said, okay, I have to replace it. I did a rewrite of this library. The API was clear, so it was easy to maintain, to replace it. The test was fast, and I have modernized it. And half a year later, they requested me to do a fundamental change. Okay, we do it within a few days. I think it was what was the feeling that I have to do something, but it's because I cannot change, I cannot improve this, it cannot add anything to the additional features to the existing library. That was the feeling, that was the experience, and that was the decision to replace it, to modernize it, to be prepared if some things have to be done. And half a year later, they just requested me, and was easy to do. Yeah, and try to identify things that could come. Yeah, be prepared. Yeah, it's not possible to be prepared for everything, but it's a fault not to say I'm prepared. Yeah. Other experiences, black holes are very resistant. Even if you are trying to replace them and you tell everybody, yeah, there will be a project that needs some core functionality, and they will add something. Yeah, they will do the hack. As long as this black hole is not removed, it will attach new things. Yeah, it's really fascinating to see how black holes are very resistant. Yeah. Sometimes another thing happen. If you say it's redundant, it's always seen as this is not a good idea. But I think if you want to reduce some dependencies, if you want to kill something, if you want to restructure your code, sometimes it's really important to accept redundancy. And especially if you just copy glue code. I have so many glue code. I have 14 modules just, and the basic infrastructure for configuring some things like where's the tracking endpoint or something like that. it's just a copy. It's 14 times a copy, because it does not pay off to introduce a new dependency to it's not too complicated. Yeah. So really accept the redundancy. Just think about it. Yeah. Sometimes it's worth to build a library for things that are used only 4 or 5 times. Yeah, because they are really complicated, hard to explain. But on the other side, sometimes it's okay to copy some code 20 times, because it's just only a simple glue code. Why just introducing a new dependency on it? Yeah, really important. I've shown you, invest in development tooling. Yeah, nobody gives you OAuth2 server. Yeah, for development, nobody builds it. Yeah, if you say the team, I need a sandbox, it takes time. Yeah. You need it immediately, and it's easy to build. A lot of development tooling, all your requirements for production, secure. No, of course, this development or server is not secure. Yeah, it just fulfills the protocol, but all requirements for security, it's development tooling. Yeah, SMTP protocol just realizes on the disk. Yeah, it's simple written. But you have to invest in this development tooling. You have to make it available. And in fact, the most power comes if you have completed your development tooling. If you don't need any environment, if you don't need external systems, yeah, you have seen that there are several things that have to be mocked away. Yeah. Vendor lock-in. yeah, that's really a story for its own. Yeah. Often you use vendor-specific statements, and it's really hard to mock vendor-specific things. Yeah. So what I did is I replaced every vendor-specific things. It was especially SQL, Oracle SQL, and try to find a solution. It's only built on Hibernate, and sometimes you need some refactorings that spread to the other systems. For example, I had a query based on the database link, and I had to hide this database link in the database. Just introduced a few, and that worked. Always you have to clean your architecture. You have to think how it is better structured. And this gives you a lot of control. And the most important thing is really synthetic test data. Synthetic test data is a blessing. My experience with synthetic test data is really, it makes your life so easy. Don't ask somebody to give you test data, just write it yourself. And it's so many time that you don't have to wait. It does not delay anything. And really, I'm really convinced of synthetic test data. So a few others observations and thoughts. I've talked a lot of technical debt, and you can see this technical debt. In fact, you can see that a lot of IT systems of most banks, that they were initially designed for internal usage only. And you can see it if you log in. You use the account number for logging in. Every other portal, every other front-end web page, you use something like email address or a nickname or something like that. And if you use the internet banking of most banks, you have to enter something like an account number and a PIN that was sent to you by the bank. And that shows that the model is somebody becomes a customer and then he uses services. And the identifier is the account number. When I was a young boy, my father went to the bank and showed his bank card, and then he got his account statements. 40 years ago, unbelievable now. But in fact, it's the same now. You show your card at the internet banking, so you have to type your account number, And as you cannot show the card and cannot be validated in any other way, you have to enter a PIN. Yeah, and then you see it's a thin layer. There's a lot of things that have to be done, and I'm very glad that we addressed this problem at ING DIBA now. We use the account number also. We will refactor it. We will really build a better customer experience here. Will be a large project. Will address a lot of things, but I think it's really important to do it. I've just had a look at some competitors, and it's really frustrating. I found a bank, they have to enter 3 digits for a branch, 7 digits for your account number, 2 digits for your sub-account number, and then your PIN. Yeah, and you see the legacy systems blinking up in the login mask. Yeah, you know they support up to 1,000 branches. More is not supported. The account number, okay, as they have sub-accounts. I think the account number is also the identifier for the customer, so it's a customer number, and they every customer can have up to 100 accounts. Not more is supported by this IT system, and I think they should do a lot of things to make the things better. Yeah. It's also complained about the maintenance costs are higher than the development costs. Yeah, I think it's clear. Management does not invest in maintenance. Yeah, it takes time. You have to do a lot of things, and they accept that the speed of development decreases, and that's what I really don't like. I think the attention should be much higher. You have to invest so that you can change systems, that you modernize systems. That's what I think. It's also, I think the interest rate of technical debt is really high. I think my experience is it's higher than return on equity. Yeah. If I see something that I want to change, I don't have the time and say, okay, will take about 5 days. I don't have the time of this 5 days. And then I go to the same thing 1 year later. I think it will take about 6 days. Yeah, this is an increase of 20%. It's very subjective. Yeah, it's not validated in any way, but it's feeling that technical debt has a real high interest rate, and it's really worth investing. Yeah, especially as it's not only investing, you have to be patient, and it takes time until you see the effects of your investment. Yeah. What also is when you have a well-maintained system, yeah, it's clear how it works, and then it's easier to migrate. But if it's well designed, the need to migrate it is not so high. So I think often people focus too much on technology instead of how good do the systems work. I'm convinced that a well-maintained COBOL system is worth a lot. No? Really, even if the technology is outdated, people are expensive, it's not so fast. But if the data model is fine, the system works fine, it's well designed, you always have the chance to change it. You always have to change to migrate it. If you really have to migrate it, a well-designed, maintained system is easy to migrate. So that are really investments, and I think it's worth mentioning it. That's what I think. Yeah, and to give you a small example, it was in the press a short time ago that the IT integration of 2 banks was finished. The takeover started in 2008, and it was finished in 2023. Wow, yeah, it really took a real long time, and I think this is really a warning. Yeah, it's not assume a car maker merges with another car maker, and they take in the takeover process takes 15 years. Unbelievable. Yeah, And in IT, because it's massively based on IT, suddenly this is acceptable. I don't think that it's acceptable. Things change really rapidly. Yeah. There are a lot of competitors coming up that we don't expect now, but they will arise in a few years. Don't know. I think a lot of people or companies that use technology really will offer some new services in a financial way, and we have to adopt. We have to react, and if we don't have the time to react because IT projects take such a long time, I think this is a real threat for the business model of a lot of banks. So yeah, I think the timeline is really interesting. Yeah, occurrence of the iPhone until now, and nearly matching this IT integration. I think this is really a warning. Yeah, it's really saying invest in your systems, improve them, let them evolve. No? Don't believe in okay, if it does not work, we will replace it with a new system. This does not work. It's the same. You have to integrate with the system. So yeah, I say invest in maintenance, invest in your existing systems, try to structure them better, do it, yeah, and don't wait until you have to do it. Okay, thank you for your attention. I hope it was interesting for you. Some legal remarks. I used some pictures from the internet. I want to mention them. I want to mention the license. And yeah, thank you very much.
Hans, hello again. Thank you so much for the talk. So we are really low on time, but I would say let's tackle at least one question for the Q&A, if you're still up for it.
Yeah.
Yes, perfect. Then let's take the first one. What changes do you expect in combining new technologies with legacy systems? How can businesses prepare for these upcoming shifts?
Changes do I expect? A good question. The thing is, you don't know what a new technology brings with you. So you have to analyze what do I have to do. The only thing is that you can prepare your legacy systems. I mentioned something like batch jobs that deliver data late. This is really, you have to address it. You have to prepare for it because the new technology will be near time. The expectations of customers is near time. Yeah, so you have to address these things. Then it will be easier that new technology can be combined with legacy systems. Yeah, think what's coming up. Yeah, near time things, fast reaction. Yeah, I think something like opening an account. It becomes a pending state. Is not up to date. Yeah, those are the real deep technical depth. And if you address this, it's easier to combine new technology. Yeah.
All right. Thank you so much, Hans, for answering this question. And thank you so much for your talk and joining us today. Hope you have a nice rest of the day and maybe see you on another live day.
Okay.
Bye-bye.
Have a nice day.